The cone of opportunity is an air traffic control vectoring concept that assists in ensuring aircraft receive a proper interception of final approach course. Depending on certain factors like visibility and ceiling, there are certain points where ATC must vector outside of for the final approach course interception. Basically, either the approach gate or 2 miles from the approach gate, depending on the situation. For demonstration purposes of the cone of opportunity, let's suppose that we're dealing with good weather, no wind, and a single runway. So we can vector aircraft so that they intercept the final approach course no closer than the approach gate, okay, which is 1 mile from the final approach fix, with a maximum intercept track of 20 degrees. So this is runway 28 here at Academy, and our max intercept tracks in this direction that we normally issue to the aircraft. If this is runway 28, then you have 260, and on the south base leg it would be 300. Okay? So here's how we visualize the cone of opportunity. We take the closest point of interception on final, which in our case would be the approach gate, well, denoted by this little red dot there, and we draw 2 lines outwards from that point on the reciprocal of the max intercept tracks. So what I mean by that is we again take our closest point of interception, which in our case is the approach gate, and we draw 2 lines outwards from that point on the reciprocal of the intercept tracks. In this case, 260. So the reciprocal of 260 is 080. So we draw that line there out like that as far as you'd like. And we draw another line outwards from our closest point of interception on final on the reciprocal of 300, which is 120. And that area there, this area here, is the cone of opportunity. And what happens is that if an aircraft is in the cone of opportunity and on a track, in our case a 20-degree intercept track, then the aircraft will have a legal turn on to the approach, a legal intercept. So in this case, let's clear some of this out here. We don't actually need to wait for Southwest to get closer to final, so we don't need them to be about here before we issue them an intercept heading for the final approach course. We can actually start issuing them the turn now, because by the time we issue them the turn and by the time they actually turn and are established on the track, they will be in the cone of opportunity and they'll be going in that direction and they will have a good intercept. I'm going to go ahead and show you this here. I'm going to play the animation. And again, we can go ahead and give Southwest that 260 heading now, and they'll start turning here in a moment, which you'll see in front of American. There's no need to wait for Southwest to come closer. They are in the cone of opportunity. Okay, Southwest is in the cone of opportunity. They should be turning here any second. Okay, and you'll see once the aircraft rolls out, and if they continue on that track of 260, they will intercept before our closest point of interception on final, which is what we need, and they fit nicely in front of American. Okay, so that's one application of the cone of opportunity. Another application of the cone of opportunity is sometimes you may have pilots that make inconsistent turns when you're vectoring. You might notice sometimes an aircraft will turn very quickly and then other times very slowly, so the rate of turn can be somewhat unpredictable if they're a training aircraft. It doesn't happen often, but it can happen occasionally. If that's the case, you really want to avoid bringing that aircraft who has a volatile turn rate closer to the cone of opportunity, because you're going to have to be more accurate with turning that aircraft, you're going to have to make sure that they really do turn when you need them to turn. You're going to need to be more accurate. And the closer you get, the more difficult it is to be more accurate given their turn rate fluctuates so much. Okay, so what you can do with the cone of opportunity to still provide them a good service is just take them out a bit farther where you have more wiggle room, okay, and wait until they're basically in the cone of opportunity. If they turn really quick, and we're talking about this little aircraft down here, let's say they have really inconsistent turn rates, well, you bring them out a little further, and once they're basically on this line or just inside of it, they can turn instantly and make a very quick turn. And as long as they're on the 300 track, then you'll still be fine. So they can turn very quickly and you'll still have a good intercept. Or since you brought them out a little further, they can delay, they might delay, and that's okay because they'll still eventually, hopefully make that turn, albeit slower, but they'll eventually be established on the 300 track and they'll still have a good intercept. So that's another way of using the cone of opportunity. Let me speed this up a little bit, jump ahead, and I'll show you what I mean. So let's say that November 1, 2, 3, 4, 5 has been making very inconsistent turns when we issue them vectors. Sometimes they turn very quickly and sometimes they turn very slowly. We'll go ahead and issue them the 300 turn now. And even if they turn instantaneously to that 300 heading, you'll see that they'll still have a legal intercept. Or as you can see, they are ending up making a slow turn. They're delayed response now. So we're waiting for them to turn. It's been several seconds, still waiting for them to make the turn. Again, we issued them that almost a mile ago, and they're still waiting to turn. Okay, there they go. They made a turn, albeit delayed. And as you can see, they're still in the cone of opportunity. They're within that region, and they're established on that 300 track, and so they will have a good intercept. I'll fast forward this for you to see. As you can see, they're going to intercept the final approach course outside the closest point of interception on final, and that's what we want. That is a quick explanation and application of the cone of opportunity.